Hey folks, we're into section 2-3. We're going to be looking at annuities and perpetuities again, but this time we add growing annuities and growing perpetuities to our list of shortcut formulas. So this is the type of perpetuity you already know, the zero growth rate perpetuity. It pays a fixed amount of money every year, forever, starting in year one. But there's also a constant growth rate perpetuity, a growing perpetuity, which pays an amount each year, starting in year one, forever, but the amount isn't fixed. It grows each year by a certain percentage, by a certain growth rate, a constant growth rate. So maybe the first payment in year one is $100, and maybe the growth rate is 20%. So in year two, the payout's gonna be $120. And then in year three, it would be $144. So a 20% growth in the payment each year. There's a similar idea when it comes to annuity. This is the kind of annuity you know. This is a 3-year annuity starting in year one. It's a zero growth rate annuity. It'll pay 3 fixed payments over a 3-year period. But there's also a constant growth rate annuity. This is also a 3-year annuity. You will receive 3 payments, but the payments are not the same size. The payment in year one, well, let's say it's $100. Well, if you have a 10% growth rate, in year two payment is $110, which means your year 3 payment would be $121, because again, you have 10% growth each year. Still a 3-year annuity. So let's review our basic zero growth rate perpetuity formula. Just take the cash flow in year one times the perpetuity factor 1/R. But it changes for a constant growth rate perpetuity. Now we have the cash flow in year one times 1/R minus G. The discount factor is now, the perpetuity factor is now 1/R minus G, where R is the discount rate and G is the growth rate in the payments, like a 20% growth rate or a 10% growth rate or a 3% growth rate or a 2% growth rate, whatever it might be. Likewise, this is our zero growth annuity formula. You've already memorized it. And here then is our constant growth rate annuity formula. It is not looking very much like the original formula. You'll not notice, not only is an R minus G kind of created and factored out here, but there's also a 1 plus G to the T term. So you're gonna have to memorize this. It is not like the original annuity formula. It is different. If you're wondering why it kind of differs by more than just R minus G in place of R, you'll have to look at a derivation. You can find a derivation for these kind of formulas, or at least the concept of it, on the bottom of page 34, or you can look up derivation of a constant growth rate annuity formula. I think for our purposes, memorizing will be sufficient. All right, time to test your knowledge. Get out a piece of paper, pause the video, and write down the present value formulas for each of these 5. All right, this is what you should have come up with. Let me just note a few things. The present value of a cash flow in year T, all right, is the cash flow in that year times the discount factor, the T-year discount factor. For the perpetuity, you multiply times the perpetuity factor. For the constant growth rate perpetuity, times the constant growth perpetuity factor. A T-year annuity times just the T-year annuity factor, and a constant growth rate just times a constant growth rate annuity factor, which includes the 1/R minus G times 1 plus G to the T over 1 plus R to the T. Again, a little different, so memorize it. All right, now let's really test your knowledge. Again, pause the video, Write down the present value formula for each of these. Take your time. When you're ready, unpause and see how you did. All right, how did you do? Did you get them? Go ahead and check your work. And then take note of this. The cash flow is always going to be, for something occurring in year t plus 1, is going to be the cash flow in year t plus 1. Note, I put the perpetuity and annuity factors in blue, and then the discount factors in red. All right, let's revisit a problem we've seen and then modify it. You're looking for an investment property. A house in Sabino Canyon is selling for $450,000. You think you can sell the house in 3 years for $550,000. You think the investment is about as risky as the stock market. You can rent out the property for $18,000 per year or $18,000 per annum for the next 3 years. Should you make the investment? Do you remember how to build the table? Pause it for a second and build the table. Once you've built the table, pause it and write the formula for the present value and calculate it. See if you can do this problem. All right, here's the table you should have created. 450 outflow right now times 0, 550 inflow in time 3, and 18 inflow in each of years 1, 2, and 3. Of course, this is in thousands. And here's the formula you should have come up with. The 450, don't have to do any discounting on that, it's in time 0. The 550, use a 3-year discount factor. The 18 is a 3-year annuity starting in year 1, so just use the 18 times the annuity factor. And you should have gotten $7.99, which is in thousands again. So that's $7,990. Let's modify the problem now. A house in Sabino Canyon is selling for $450,000. You think you can sell the house in 3 years for $550,000. You think the investment is about as risky as the stock market. You can rent out the property for $18,000 in year 1, for 5% more than that in year 2, and for 5% more than that in year 3. Should you make the investment? Okay, see if you can make the table. Then see if you can create the present value calculation and get a proper present value. Go ahead. All right, this is the table you should have come up with. The 450 and the 550 are the same. But now, while you're going to get an inflow of 18,000 in year 1, in year 2, you're going to get 5% more than that. So you take 18 and you multiply it times 1.05, 1 plus the discount rate, and you get 18.9. Then you take that and multiply it times 1.05 to get 19.845 in year 3. You have a growing perpetuity. What rate is it growing at? 5% per year. It's still a 3-year annuity. This time, it's a growing annuity, growing at 5% per year. And what did you come up with for a calculation? Should have come up with this. Notice the formula is no longer just an annuity formula, 3-year annuity formula. It is a 3-year growing annuity formula. What rate's it growing at? 5%. All right, so of course you're going to make this investment. I mean, you were going to make the investment before when your perpetuity is stuck, your annuity is stuck at $18,000 a year. Here you're going to make the investment for sure, because your annuity payments are growing by 5% a year. That can only be in your favor. So instead of $7,990 in net present value, now you got $10,116 in net present value. Remember, this is in thousands. Let's revisit this old problem. The year is 2040. Elon Musk has successfully transformed the automotive, power generation, housing, and commercial space industries. He's the first trillionaire in history. With his vast fortune, he creates an endowment to fund explorations of the universe. He structures the endowment to provide $100 billion per year for space exploration in perpetuity starting in the year 2041. The stock market is still returning 10% per year on average. How much does Elon need to deposit into the endowment fund in 2040 to fully fund this endowment fund? See if you can do the calculation. All right, here's what you should have come up with. Easy calculation, we're dealing with a perpetuity. Beautiful. And you should get, how much money is that? How much money is the present value? Can you read that? That's $1 trillion. 100 billion divided by 10% or 0.1 is $1 trillion. All right, let's modify the problem. Same scenario, except now he structures the endowment to provide a perpetual stream of grants starting in the year 2041. The first grant in 2041 will be 100 billion. Every year after that, the grant amount will increase by 7% per year. Stock market still returning 10% per year on average. How much does Elon have to deposit in the endowment in 2040? Again, what's going on here? You still have a perpetuity, but it's no longer a fixed amount. It's no longer a zero growth rate perpetuity. It's now a constant growth rate perpetuity with a 7% growth rate. So what are you going to write here to come up with the present value, and what are you going to calculate? Give it a try. All right, here you go. Now it's the cash flow in year 1 times 1 over R minus G. What's R? Discount rate. That's 10%. That's the opportunity cost of capital. What's the growth rate? In the payments each year, 7%. That's G. All right, so now how much money does he have to deposit for this much more aggressive form of perpetuity? Can you read that number? The present value equals 3,333,333,333,333.